concept for this type of question has to do with the fact that if you have parallel lines have slopes that are equal to each other. Okay? So if the original line has a slope of a over b, then the parallel line will also be a over b. If you're dealing with a perpendicular line, then its slope would be the negative reciprocal, so negative b over a for a perpendicular line. In this example here, we're looking at a parallel line. So if we take this, and again, I'll kind of talk through Desmos as well, but if we take this by hand and we see that we have this given equation right here, y equals 8x plus 3, and the line that we're trying to find passes through the point 0, 0, we can plot that given point. And if you know that the slope of this given line is the coefficient of x, right? It's y equals mx plus b. So here's your slope. That means our slope is 8. So the line that we need to draw is going to have a slope of 8 and pass through this point 0, 0. So a slope of 8 gives you the equation y equals mx plus b. We know that our slope is 8 because they're parallel, right? The line or the slope of the parallel line will also be 8. And the y-intercept is this point 0, 0. This is your y-intercept. So you just have the equation y equals 8x. And so really what this is asking you to do is evaluate that function, that equation, at the point x is 5. So if you were to evaluate y of 5 is equal to 8 times 5, which is 40, and that would be your answer. If you're doing this on the Desmos calculator, if you type in the given equation, 8x plus 3, what you know is, we'll zoom in here, you know that you need to create a line that is parallel to this, and it needs to pass through this origin. So if you took the line y equals, same slope, 8x plus some unknown, right? This is where that slider comes into play. If you don't know what your, or I'll call it b since it's a y-intercept. So if we don't know what b is, what we can do right here is we can, find where does this line pass through the origin. And so we see as we slide it around here, we just slide that line until it passes through the origin, and when we find where it is on there, we see that it's the y-intercept of 0. And so what you can then do, and even better here, since I am going to evaluate this, instead of calling it y, I'm going to give it the name of a function. You can use function notation on Desmos, because here we're looking to identify what is our y value, the output, when x is 5. So if we just take our function at 5, we see our corresponding output of 40, and that would be our answer. So you can use Desmos for this as well, although you're doing pretty much the same things as what you would do when you solve by hand. All right, again, if you do ever have questions on any of these, please feel free to ask. I know I'm kind of going through the strategies and hoping to show you how to use, especially either the strategic, like the methods to solve problems, or Desmos to solve it as you're going through. But if you do have a question, please ask. All right. So function notation, remember, Desmos does this for you. I do encourage you to use that because it makes it easier. You don't have to do it by hand. Question? Yes, you can use a TID9 on this as well. It's not a bad idea to do that if you're going to be taking AP tests, like also. Getting familiar with your TID9 is an advantage. Oops, I'm going to go ahead and project this out to your screens too. I'd meant to do that earlier. All right. So I want you to see if you can answer this next question, number 20 here, by using the function notation powers of Desmos. All right. Right away when you look at this problem and you see, it's just asking you to evaluate. So if you're doing this by hand, what you're doing is you're taking 4 times the f function, which is x, some placeholder, plus 7, minus g, the g function here, which is 7 times some placeholder. Well, in the f function, the placeholder is holding a spot for the number 2. In the g function, same thing. It's holding a spot for the number 2. So if you evaluate these, you would get your solutions here. And so 4 times 2 plus 7, which is 9, minus 7 times 2, which is 14. So 36 minus 14 leaves you with the answer 22. Now that's if you're doing it by hand. Okay? I encourage you to use the fastest way possible. Okay? This isn't, one of the arguments against the SAT is it's not necessarily a test of what you know, it's a test of what you know how to solve. Okay? So like using a calculator to solve things for you doesn't mean you know it, but it means that you can score like better on this SAT. So if I took this original functions and I just typed in the two functions that I have, the f function is x plus 7, the g function, and I'm just using the same variables that they give me, is equal to 7x. What I can then do in the next cell down is I can just copy what they have. So 4 times f of 2, all minus g of 2. And notice it evaluates it for me, gives me my answer 22, confirming what I did by hand. All right, see if you can answer this next even question number 22 here. Hey, this one's a little bit more on, this is a little more on the tricky side. It's rated as a medium. I don't know, like to me, it's one that like is likely to be missed, I think, than a lot of the other medium like level difficulty questions. Oh, by the way, the letters next to each question tells you whether it's rated as hard, medium, or easy. So that's what. All right, so as I go through this, I'm going to talk through like sort of the mathematical way to solve it, and then I'm going to go back and talk through another way, because you can solve this problem without having to go through all the steps that I'm going to show you. I just want to show you like the math that they're trying to test for is what I'm going to go through, but then I'll go over like an alternate way to approach this. All right, so if you're looking to set this up, what you see here is this linear form, right? You can tell by the options. Okay, it's not a bad idea to scan the answer choices before you start a problem, because it gives you clues as to what you're looking for. So I know from the answer choices I'm looking for a linear equation, and I see my rate of change is either 50 or 94, and my initial initial amount, or the y-intercept, is either 320 or 220. So I'm just trying to distinguish between the two. Okay, so when I look at this and try to set up my equation, it says that they charge 320 originally for the first 2 hours. Now that's sort of the trick to this question. Okay, so that covers the first 2 hours, and then it's some fee after that. So plus some slope for every x value after 2 hours. So you do have to represent it as x minus 2, because the 2 hours have already been accounted for in that original amount. Okay, so this is the equation that you're going to use. Okay, once you establish your equation, you can find the information that they give you is that the total cost of 470 happens, we don't know what they're charging per hour, but at 5 hours of repair. So if we plug in a 5 for our x and a 470 for our y, we can now find what our m, our slope, our rate of change is going to be. Okay, so here if we subtract 320 from both sides, that leaves you with 150 is equal to 5 minus 2 is 3, m divide by 3, you get your slope to be 50. So right away I can eliminate my lower two options. Okay. So when we plug this back in to this equation here, I get y is equal to 320 plus 50 times x minus 2. And notice what I have to do here to put it into the form that my answer choices are. Distribute my 50. So I get plus 50x minus 100. And again, notice what it does. It adjusts that constant. The y-intercept is now 220 instead of the 320 that you would likely think if you're just looking at it, right? Because you look here and you think that the initial amount you put forth is 320, but that is for the first 2 hours. And so it's a little bit different than what you might expect. All right. The other option that you can do right here is you can just start testing these values. And I'm just going to use, A, or a different letter, because I'm going to use a slider here instead of my x. But if I take each of these equations, so 50x plus 320, okay, I'll put a slider here because I am going to change the values. But I'm going to put all four of these equation options in terms of A. So I have 50A plus 220. I have 94A plus 320. And I have 94A plus 220. All right. So what I want to do is I want to see my input of 5 should give me an output that's what? When I change this A to a 5, I'm looking for the answer choice that gives me 470, right? So if I wanted to do that, I could just go up here, change this to 5, and now my answer is the only one that equals 470 because it tells me that's one of the solutions. Okay, and so I get my equation is the 50A plus 220, which would give me my answer right here. Again, without me having to go through any of that work. Okay, so if you understand how the things are working, okay, and you kind of get like an idea of how the slider can work for you, okay, it allows you to test each of those answer choices with the value that they give you and see which one is equal to the 470 or whatever the output is supposed to be. Okay? So if I'm doing this and not like again I'm familiar with how all this works, I would probably do it that way because to me that's quicker than working through the steps mathematically. All right. Go ahead and keep moving on to question 24 here. Again, for this, it's just continuing with the idea of like linear functions being in that form, y equals mx plus b, where m is the slope or rate of change, and the b is the y-intercept, okay, or the initial amount. So see if you can interpret the graph that they show you here, please. You see that your graph is a line. So you know that that's this y equals mx plus b form. And it's asking you, what does the y-intercept represent? Well, the y-intercept here represents your one-time fee, right? So that is the solution for this. The y-intercept is your one-time fee. If you wanted your hourly rate, that would be the m, right? If you knew what the rise and run was for that graph. If you wanted the total amount that electrician charges, that's the whole value y, right? That's the whole output value. And then the maximum amount the electrician charges, there's nothing really like that for that. They just needed another distractor for this option. So this question right here, if you come across this question when you're doing like practice problems on the Canvas site, there'll be different versions where each of these is the correct answer. So make sure you read the question carefully. Find out what it's asking you. Is it asking you for the y-intercept, the slope, okay, or the actual output value or the y value? All right, continuing with linear functions. Again, just emphasize that it's mx plus b is the form. Okay, I want you to see if you can answer question 26 here. I'm going to show you 3 different ways to solve this question. Again, it just kind of shows you can choose whatever you want. There's alternate ways to do these. Okay, more than likely, if I'm doing this and I read through this question, I see a couple things. First, it tells me it's a linear relationship. The key to a linear relationship is that the rate of change is constant. And so this means that I can find a slope between any 2 given points on this table, and that's going to be my rate of change. Okay, and so since it's asking me for slope, what I would likely do is I would just take the first 2 points. Remember, slope is the change in y's over the change in x's. So if I took the change in the y's there, 286 minus 250, divide by the change in x's, the corresponding x's are 14 minus 12. And so this is going to give me my answer. So if I took 286 minus 250, and divided that by 14 minus 12, I get my answer to be 18. okay? And that would be my solution. So that's the way I would probably do this. Okay? Now, let me show you a couple of alternate ways to approach it. Okay? They gave you a whole equation right here. So what you could do is you could take any one point on this whole set here in this table, and you could solve for m. So let's say I just took my first point here. What this is saying is if I get an output of 250, that's equal to some unknown m times the input of 12 plus 34. So I could actually solve for this. Now, on Desmos, if you are solving an equation, the best thing to do is to just use the variables x or y. If you use x, you're going to get solution points on the x-axis. If you use y, you'll get solution points on the y-axis. So I would probably choose x. So if I replaced the m with x, and I solved this, and then I zoomed out to see where is my line passing through the x-axis, and I see it's 18. Okay, so that's another, like a nice, easy way to do it. Just type the equation in and evaluate it using one of the table values. Okay, the final way that I want to show you, and it's not the most efficient way, but the reason I'm showing you is it just allows you to sort of get familiar with how Desmos works, is you can actually plug these points into your table. So if I hit this plus button and set up a table and just copy what they have. Now here's the thing is with when you're using regression equations, you need one more point than the power. And so a linear equation is a degree of 1. So you need just one more than 1, so 2 points. So if I just put in the first 2 points, so 12 and 250, and then I put in 14 and 286, I don't even need to put in any others. This is going to be enough to give me my equation. And the way that you call out regression equations is you use y sub 1. If you just type the 1, it automatically subscripts it for you. Is similar to. If you don't have a keyboard, similar to is in this keyboard that you can pull out here, and you go into the ABC commands, and it's located right here. So you can get the similar to, and then you write the equation that you're looking for. So I want slope-intercept, y equals mx plus b. So m times x. You do have to use x1 and y1 simply because the table's set up with this x sub 1 and y sub 1 values. And then plus b. And notice it gives me my slope and my y-intercept for the corresponding graph. And I see right here that my slope is 18. So I could have also recreated the table, used regression, and found what the slope was that they were asking me to find. Okay? So any of those methods work. It's all completely up to you what you're comfortable with. If you're using an alternate method to confirm an answer, but definitely figure out when you're practicing for these what works fastest for you. Notice my little hint up above here. It's the same as what we saw in solving for a single variable. Or an equation with a single variable, if you're being asked to solve for an expression that's a combination of terms, not just what is x or what is y in a system, more than likely there's some way that you can directly manipulate the system so that you end up just adding or subtracting the given equations, and it will leave you with that expression. Okay? So if I just talk through the first one, or the question 27 up here, notice what happens. I'm being asked to find x plus y. If I just combine my terms straight down, 7x minus 6x leaves positive 1x, 0 plus y equals y, 63 plus a negative 49 equals the 14. And so I see that x plus y is 14. So it leads you directly to the solution. You can just combine straight down. Well, that same process holds true here. Right? If I take this equation, this system, and I just combine straight down the columns of like terms, I get x plus x is 2x. 2 minus 2 cancels, it leaves 0. Negative 4y plus 4y cancels, leaves 0. 8 plus 16 leaves, 8 plus 6 leaves 14. Divide by 2, I don't even need to divide by 2. I don't need to know what x is. I simply need to know what 2x is. Well, 2x is equal to 14, and so that is my answer. Okay, now, the other thing that can happen is the Desmos allows you to solve systems graphically. So you could have also typed in the two systems of equations directly into Desmos. So there's my top equation, and then my second equation. And I see here, scroll in, what Desmos gives you is it gives you the intersection points of systems, and it gives you the x and y intercept. So if I click this purple line, notice I have my x-intercept here, I have my intersection point. If I click this black line, I have my x-intercept and I have my intersection point. So what I see is my intersection is the x value of 7, okay, and so the y value is negative 0.25 or negative 1/4. But x equals 7, and so 2x would be 2 times 7, or 14. So even if you did it that way, you're still going to wind up solving the equation the way that, or finding the answer that you need. But if you're being asked for an expression and not just a single variable, look to combine your systems directly, and they will often lead to the correct answer. All right, so try question 30. And notice again in the notes over here, when you have a system of equations, there's 3 possibilities. You can have one single solution. That's where the two graphs intersect one time, the two straight lines intersect one time. And you can have no solution. If that's the case, the graphs never intersect, which means they're parallel to each other. And then you can have infinitely many solutions. If that's the case, then the graphs are just 2 different ways to say the same thing. They're actually both, they can both be reduced down to the exact same expression or equation. Okay, so in this problem, when it asks for infinitely many solutions, what that means is ultimately you want those 2 graphs to, or those 2 equations to be the exact same thing. Okay, and so for me to convert the second equation into the first, what would I need to divide each term by? 20 divided by what gives me 4? 5. So if I divide everything by 5, right here, I get 4x plus 3y is equal to a over 5. And so now I know, in order to find what a would give us this infinite many solutions, is when 7 is equal to that expression a over 5. Multiply both sides, or cross multiply to get rid of your fraction. A is equal to 5 times 7, which is 35. All right. Desmos can be used here as well, because if you're dealing with this system, you have that unknown a. So if I type the given equations, an alternate way to approach this, you still do need to understand that a system with infinitely many solutions is going to be the exact same line, so they need to superimpose on each other. And so again, when you add this slider, it just allows you to change what a is. And you know a has to be one of these 4 answers. So I don't even need to test, I don't need to keep sliding like minuscule here. I actually just need to test these 4 things. So let's say I test 35. Notice when I do that right away, when I test this 35, I can hide 1 and hide 2. I see that they're just superimposed on each other. So I know right away from the very first one I test that that's my answer, and I can stop right there. But if I test the other ones, I test 5, notice they're not the same. I test 30, notice they're not quite the same. I can zoom in, they're not the same line. And then I test 7, again, they're not the same. They're just the parallel line. So I know the only one that works there is 35. And if you need to, kind of see where did that line go, I can use the slider and see there's where it gets superimposed right there. I can stop and get my number. But again, I don't have to test an infinite number of possibilities. I'm only testing these 4 values. All right, questions on that using the systems? The one other thing that, let's How many of you are planning to use your TID9s? Okay. Let me show you how to use your TID9 to do a system of equations, because if you haven't had me show you, you probably don't know. Not many of the other teachers here know how it works. Okay, so if you want to pull out your TID9, you can. I'm going to go back and I'm going to do this problem right here. Okay, I'm going to do this same problem on the TID9 just to show you how to find what x is equal to. All right, so built into your calculators is something called a system solver. I refer to it as a system solving template. Okay, so let me clear everything here. All right, so it's not easy to find. It's not intuitive on this, but these tabs up along the top of your TID9, okay, this is your the basic tab. These are your normal tabs up here, where algebra tab is F2. But if you see here in this, if you hit second home, where it says custom right there, it creates this new set of tabs. These are the custom tabs. And inside the custom tab is this system solving template. Notice here that F3 now has these solve commands. So if I go in and I highlight the solve commands, what I can do into this is the system solving template. So if you move your cursor over and you just start typing your equations in. So let's say I type x plus 2 equals -4 y plus 8. Notice I scroll over, okay, and there are these spaces here. Okay, if you accidentally delete a space, so I did that here just to show you, but if you delete a space right here, you can always add a new space by hitting the alpha key. And then this change of sign key, notice it's just this white underscore button. That gives you a space in your commands. The other thing that often happens is students inadvertently wind up with this cursor. So notice that my cursor is now this thick block cursor that overwrites everything. So it doesn't just insert new text in between, it overwrites it. You don't want to overwrite. If you ever wind up getting to this block cursor, just hit second backspace. Notice here where it says insert and delete, or this delete button right here, it just toggles back and forth. You don't want to delete over the top of things. You just want to insert it. So just toggle to get that back into this insert mode. I'll type my second equation, x minus 2 equals 4y plus 6. Okay, and I don't have to do anything else. Now, as long as I'm using x's and y's, this is set up so that it will solve your system for x and y. So when I hit enter, if you remember, the answer was 7 and -1/4. So here I see x equals 7, y is -1/4. And so I would have to take 2 times 7, which is 14, and that gives me my answer. Okay? But that's just a system solving template. It's in this custom tabs. Now, if you need to get back, you just hit second home again. It'll toggle back to that normal set of tabs where the F2 is your algebra tab. But if you need it, again, it's second home, go to your custom tabs, hit F3 solve, your system solving template's right below that. Okay. You can use this if you're in a math class. You can use this for 3 variables as well. If you needed another variable, just type comma z, and then here after this second equation, you would just alpha lock, hit the underscore, type the word A and D underscore, and you could type a third equation in there and include the variable z with it to solve that system using 3 variables. Okay. Let's jump to the linear inequalities. Okay, so see if you can answer question 32 here, please. And so here, for a lot of the linear inequalities, you're just modeling what the situation asks for. And so here, if you say that this elephant weighs 180 pounds at birth, and then gains more than 3 but less than 4. So if you want to put the limits on that, okay, you're going to take 3 pounds each day for 365 days, compare that to starting at 180 and gaining 4 pounds per day for 365 days. So there's what your number needs to fall between, right? So if you're saying W needs to fall between these two values, it's just calculating what you have. So 180 plus 3 times 365. There's your lower limit. You don't even need to do anything else because once you found the one part that's correct, you're good. There's no other answers that would start with that. We can confirm like the upper limit, 180 plus 4 times 365 is 1640. That just confirms that, but we already knew from the first one that that would be the solution. The last question to go through from the Algebra 1 topics, okay, is this question 34 again, a linear inequality. Go ahead and see if you can interpret what they give you and solve the resulting problem. All right, for this problem, let's interpret what we have here. So if we just kind of go word for word through, x is at most. That means that it's going to be less than or equal to. It can equal it, but it's likely going to be below it. 37 less than. Okay, so the one thing, the biggest mistake that students do make, and these are similar questions that have been on the SAT for a while, is that you don't always just go from left to right. If it says something less than or more than, put it at the end. Okay, so 37 less than means that we're taking some value and we're subtracting 37 from it. Don't put 37 minus. Again, that's probably the most common mistake would be to do that. 3 times the value of y, 3 times y. And so this gives you your inequality. If you set these, now the less than or equal to, you can either hit the less than symbol followed by the equal sign, and it'll convert to this. You can also find it in the keyboard right here for the different inequality symbols. But that is less than 3y minus 37. If you go up here and double check, when you are looking at this problem here, okay, if it tells you here that the value of y is 11, what we want to do is we want to substitute that in. Okay, and now you can see it says what's the greatest possible value of x. You see that -4 is your answer. Notice the line is a solid line. It's not a dashed line. So you're going to put -4 as your solution. Okay, if you're solving this by hand, you would continue from right here and do the same thing by hand. 3 times 11 minus 37, and just continue with what you have. Oops. Okay, but take advantage of the ability to use the calculators. Okay, I do recommend bringing your TID9. Okay, so if you are comfortable with it, use it. Desmos offers, like I think the regression stuff on Desmos is way easier to do than it is to use your TID9 for that. Although you can, if you have questions on, if all you want to do is use TID9 and you have questions about regressions, come and ask me. I'll walk you through that. There might be video captures on some of the questions where I'm doing it with a TID9 also. But I strongly encourage you, like, take advantage of what's easiest for each thing. Okay? And that kind of leads to the next topic for Algebra 2. Desmos doesn't do much for helping with factoring. Your TID9s do all the factoring for you. So definitely, if you have your TID9, take it, and any time that you're doing a problem with factoring, use the TID9. All right, so that is the main topics from the Algebra 1 concepts that you could expect to see on the SAT. Okay, we're going to start talking through the main concepts from Algebra 2 topics, which is just higher degree polynomials for the most part, and a little bit of exponential functions. All right, so I want you to see if you can answer. So now we're shifting into Algebra 2 concepts. Okay, so see if you can solve this first problem here. All right, Your options here are you can either try expanding the given rational expression, combining your like terms, factoring the result of that, and then canceling any common factors, which really does overcomplicate things. Okay? Or if the ideal thing to do, if you're going to solve this by hand, is to look to see you have these two groups here with a common factor. X minus 2, that whole binomial is a common factor. So what I would do is I'd take that out as a factor. That would leave a 5x and a minus 9 to form another binomial. And that's all over 6x minus 12. You can remove a common factor of 6, leaving x minus 2. And once you do that, you can now see the equivalent forms. These common factors of x minus 2 cancel, and you're left with 5x minus 9 over 6. Okay, if you are doing this problem on your TID9, if you go back to your normal set of tabs right here, the F2 algebra tab does have this factor form. And so you can, on this, actually, let me see if I just type the expression. Okay, it's possible that if I type the expression here, it would reduce this down into this fully factored form. If it doesn't, then I'll come back and add the factor for it. So let's take a look at this first. So if I take my expression 5x, notice I put it in its own set of grouping symbols. All right, before I move on, though, let me talk about a couple things. All right, so notice how I started typing the numerator here. 5x, we read this as 5x times x minus 2. TID9 doesn't understand implied multiplication if it follows a variable followed by any other symbol. So it understands that this x after the 5 implies multiplication. This is 5 times x. It does not understand that this is supposed to mean x times this quantity. Okay, so anytime you have a variable followed by either a number or a parentheses or any kind of grouping symbol, you need to explicitly multiply. If you tried that and you left it like without this, it would give you an error message that specifically says, like no implied multiplication. Okay, so here's my numerator, and then that is, what, minus 9 times. Now notice following a number like 9, it's fine. It understands that that's implied multiplication. Okay, so there's my numerator, divide by this quantity, 6x minus 12, and let's test this and see. Yep, so like you don't even need to put anything. If you write your expression here, it will automatically factor it, simplify that, and you can see or confirm that it gives you the same answer. All right, so try question number 38 here, please. So if you are doing this by hand, expanding terms, I'm going to vertically stack like terms for what I would do if I'm working this through. So distribute the negative. Minus a minus gives you a plus 3x cubed. Minus a positive gives you the negative. And then if you combine straight down here, you get 9x cubed minus 9. Notice it's asking you for b. B is the coefficient in front of that third degree term. And so your answer would be 9. If you used the calculator for this, you could as well. It's possible. I'll talk through it here and kind of walk through. But if you type this directly in with the grouping symbols, there is a possibility that you might need to use the expand command because the answer is asking for this polynomial form. I'm going to go ahead and type it in first, see if I need it, and then if I need it, I'll show you a little bit of how you can add that. A couple other things regarding the TID9. There is a difference between this subtraction key right here and this change of sign key right here. They're not interchangeable. Okay? If you start with a negative number, you need to use the change of sign key. If you're subtracting as a mathematical operation, you need to use this subtraction key. So here I'm subtracting, and then I put the negative number in, so I have to use the change of sign key in front of that 3. Close that off. Okay, so notice here it is, oops. I wrote the wrong number here. This should be a 7. plus 7. All right, so there is my expression, 9x cubed minus 9. I see that the coefficient of my third degree term is 9, so it confirms that I got it right. All right, the final question for today. Try question number 40, please. So this is just working with the properties of exponents. Okay, once again, you have these two separate expressions, or two separate terms to this expression. And so if you distribute this through, when you multiply exponents with the same base, you add their powers. So here I get x times x, I add -4 plus 3 is -1. Y, there is no other y, so y to the 9th. Z, there is another z, so I add, when I multiply exponents with the same base, I add their powers. So 6 plus a -2 is z to the 4th. Okay, now, as I start to work through this second part, okay, what I notice is that I can eliminate two of my options. Okay, I would have paused right here and checked, does this eliminate all of them but one? If it does, then I don't even have to go any further. Here, it didn't eliminate all of them, so I do need to continue working through this, but there are times where it does, and you can save a little bit of time there. So when I distribute through, nothing cancels with the x, so I get x minus 4. Right away, I see that this top one doesn't have that, so I can eliminate. Process of elimination can save you a lot of time. Remember, for the SAT, you don't need to find the right answer, you just need to identify what solution is correct. And so sometimes that involves like eliminating the ones that you know aren't, and just going with the one that is remaining. Okay, if I had continued to do this, again, like following the properties, the y's, I add them, y to the 9th plus 1 is 10. Z's, I multiply, I add their powers, so 6 plus a -1 is a 5. It confirms that that's right, but I didn't need to do those last few steps.